Hello students, welcome to the concept relationships between pixels, a concept in image processing. See, you know the conventional indexing method of an image. Pixel 0, 0 is the starting pixel. This is x-axis and this is y-axis. All these are yes, columns, and you know the columns are n. All these are rows. The rows are represented with m. What is the representation of an image? An image is represented like m by n image. Means the image has m rows and n columns. Okay, see this indexing method. Suppose if you take this x comma y is the reference pixel. Suppose if you take this pixel, yes, this column is same, so hence x is same, but the row number is decreasing, that is the reason, means the y is decreasing, that is the reason the pixel is represented with x comma y minus. Suppose if you see this pixel, same column but row increases, means y increases, so it is x comma y plus 1. Okay, in the similar manner, yes, you can get all these pixel notations. Yes, now first I'll define the neighbors of a pixel. Okay, that is the first relationship between pixels, that is the neighbors or neighborhood. A pixel P at coordinates x comma y means this is the pixel P. For this pixel P there exists two horizontal and two vertical neighbors. These two are the horizontal neighbors and these two are the vertical neighbors. So totally we have four neighbors. The four neighbors are represented with the n4 of P, and these are all the pixels, the four neighbors pixels. In the similar manner, the P has the four diagonal neighbors like this. These two are two diagonal neighbors and these two are the diagonal neighbors. And those diagonal neighbors are represented with the ND of P, and these are all the pixels. And combinedly you have 8 neighbor pixels for the pixel P. Okay, means ND of P and N4 of P together are called 8 neighbors of P, represented with N8 of P, and these are all the pixel notations. The set of image locations of the neighbors of a point P is called the neighborhood of P. All this set of neighbors is called neighborhood. Suppose if the neighborhood is not having P, the neighborhood is said to be open neighborhood. Suppose if it includes P, the neighborhood is said to be closed neighborhood. Then, I'll define another relation called adjacency and connectivity. See, to define adjacency or connectivity, the first and foremost thing is you have to define a set called V. What is this set V? It consists of intensity values of the pixels. You have to define adjacency or connectivity only for the pixels whose intensity values are in V. Suppose for a binary image, if V is like this, V is represented like a set 1. Means you have to define the adjacency or connectivity only for the pixels having the intensity 1. Suppose if you take grayscale image, yes, and assume that all these are the intensity levels, you can define adjacency and connectivity only for the pixels whose intensities are 180, 181, 182, etc. 200. Okay. So for the grayscale image, the set V may be any subset of these 256 values. Then, if you go for adjacency, go for types of adjacency. You have 3 types of adjacency: 4 adjacency, 8 adjacency, and M adjacency. What is meant by 4 adjacency? 2 pixels P and Q with values from V are 4 adjacent. Okay, the first and foremost thing is those 2 pixels P and Q must be in the set V. When you can call those 2 pixels or 4 adjacent if Q is in the set M4 of P. Okay, and 8 adjacency. 2 pixels P and Q with values from V are 8 adjacent if Q is in N8 of P. Okay, then if you go for M adjacency called mixed adjacency, the definition is like this: 2 pixels P and Q with values from V or M adjacent if the first condition is Q is in N4 of P, or Q is in ND of P and the set N4 of P intersection N4 of Q has no pixel whose values are from V. Means there should not be any intersection of n4 of P and n4 of Q. Okay. So if Q is in n4 of P, it is called 4 adjacency. If Q is in n8 of P, it is called 8 adjacency. If these two conditions, either of these two conditions are satisfied, yes, you can call the two pixels or M adjacent. Remember, if Q is in n4 of P, means n4 of P, you know the horizontal and vertical neighbors. Okay, in M adjacency, horizontal and vertical neighbors or that adjacency can be defined only with simple n4 of P condition. Okay, but the second condition, for the diagonal condition, you have to check the diagonal, whether Q is in diagonal, whether Q is in ND of P, and also this n4 of P intersection n4 of Q must be 0. Means it should not give any values. Okay, if that satisfies, then only you can say P and Q are M adjacent. And take one example. Okay, why you are going for mixed adjacency? Because 8 adjacency is giving ambiguity. That is the reason now we are going for mixed adjacency. What is that ambiguity? Yes, see this. This is the pixel arrangement. Here we are defining adjacency only for the pixels whose intensity values are 1. So if you take this 8 adjacency concept, see this, there exists between this one and this one, there are two paths. One path is like this, another path is like this. So there is ambiguity. Okay, so to eliminate this ambiguity of paths, of connections, we are defining mixed adjacency. Okay, now I will explain the mixed adjacency.
Yes, what is our pixel arrangement? 0, 1, 1, 0, 1, 0, 0, 0, 1. In the 8 adjacency concept, the connections are like this. One, 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 one. Okay, so there exists ambiguity between these paths. For this center pixel, this corner pixel is connected in two ways. That gives ambiguity. But if you go for M adjacency, take the same notation. Yes. Now what is M adjacency? Q is in N4 of P. Means these two are adjacent, no problem. These two are adjacent, no problem, because these, for this is an N4 of P, and for this is an N4 of P. Okay, I will circle all these ones. But now we'll check this diagonal connection and also this diagonal connection. Okay, so now take this as your P and take this as your Q. Okay, see, M adjacency is mainly to verify the diagonal connections, remember. Okay, then I'll see what is the second condition in M adjacency. See this Q is in ND of P. This is P and this is Q. Q is in ND of P, no problem. But along with that ND of P condition, the condition is N4 of P intersection N4 of Q must not have any values in V. Okay, yes, we'll see. Yes, first condition is okay. Q is in ND of P. Now we'll see what is N4 of P. N4 of P means this one and this one. We are getting only two. So what is N4 of P? Yes, only, yes, 1 and 0. Then what is N4 of Q? For this 1, 0, 0, 0. 1, 0, 0, 0. What is N4 of P intersection N4 of Q? Yes, if you take intersection, you'll get 1, 0. So what you can say? What is V actually? What is V? V is 1. Means you have to define the adjacency or connectivity only for the pixels whose intensity is 1. But if you see the intersection, you have, yes, the intensities and the V. Okay, but the condition is there should not be any pixels in the intersection, means after the intersection which are in V. Okay, so means as you have value in V, then this P and Q are not connected diagonal. Are not connected diagonally, means there is no connection between these two. Okay, now coming to another point. Consider this as P. Okay, now consider this as P. Now, what is the second set? What is this N4 of P? For this N4 of P, 0 and 0. And what is N4 of Q? Same, consider this Q. It is 1, 0, 0, 0. So, what is the intersection? Yes, the intersection of 0, 0. Yes, it is not in the set V, hence these two are connected, M adjacent. These two are M adjacent. So that is the reason the M adjacency is like this. Means you don't have ambiguity like these two paths, okay, and you eliminated this diagonal connection because of this M adjacency.
Then we'll define a path or curve. A path or curve from pixel P with coordinates x, y. Let us take this pixel P with coordinates x, y to pixel Q with the coordinates s, t is a sequence of distinct pixels. It's just a sequence. Okay, see this? This is all the sequence. This is the path. And the sequence is x0, y0, x1, y1, etc. x and yn. So what is x0, y0? The starting pixel P. And x and yn is the ending pixel Q. Okay, so you have to connect all these pixels which are adjacent is a sequence. Okay, and we know when you are going to a path, you have to go for shortest path. Okay, suppose if this x0, y0 means the starting pixel and x and yn and the ending pixel are same. Suppose if it goes like this, the path goes like this, then ending pixel and starting pixel are same, then that path is called closed path. Then suppose here is the length of the path. What is going to be length of the path? Here you have the ending pixel x and yn and the starting pixel x0, y0. Okay, then what about the length? Yes, suppose if the starting pixel is x0, y0 and the next pixel is x1, y1. And this is x2, y2, x3, y3, x4, y4, etc. x and yn means n is called the length of the path. Here also you have 8 path and m path. 8 path gives ambiguity and m path resolves that ambiguity. Now we'll define the connectivity. See, what is this connectivity? Let S represent a subset of pixels in an image. Take this image, take this total image, okay, and S represent a subset of pixels. Let us take this as S, okay. Two pixels P and Q are said to be connected in S if there exists a path between them consisting entirely of pixels in S. Let us take this as P. Let us take this as Q. There is a path. Okay. So you can say, yes, in S, P and Q are connected. Okay. Same. Yes, here also you can take another subset S. Take this as P and this as Q. So there is a path. Yes, hence this is called, these two pixels are said to be connected. Okay. So now the number of pixels that are connected in S. The number of pixels that are connected in S is called connected component. This is one connected component and this is another connected component. Here this image is having two connected components. Suppose if the image is having one connected component like this, okay, you have to consider this as P and this as Q, and there exists a path like this. Then if the image consists of only one connected component, that is called connected set. Okay, so this is about connectivity. Now we'll move to the region and boundary. What is meant by region? Let R be a subset of pixels in an image. We call R a region of the image if R is a connected set. Okay, yes, what is this? Simply R is a connected set. See this? See this total? connected set, it's a region. Yes, this image consists of region. This image is having one region. Okay. And simply speaking, a group of connected pixels that share a common property like intensity, color or texture is called region. Coming to the boundary also called border or contour of a region R is the set of pixels in the region that have one or more neighbors that are not in R. Okay, set of pixels in the region that have one or more neighbors that are not in R. Okay, see this region. Yes, for this region, what is the boundary? This is the boundary. Means, suppose take this pixel, its one neighbor is this and its one neighbor is this, and the other two neighbors are not in the region. Those pixels are called, which are not in the region, are called border, means constitute the border. Suppose if you take this example, all these ones comes under the region and all these zeros comes under border or boundary. The set of pixels that separate the region from the background or from other regions is called boundary. Okay. Suppose if you take this image, this one is, all these ones are region. The background, this region is separated using the zeros. So now all these zeros constitute the boundary. Now we'll go for the concept distance measures. This distance measure is nothing but, or distance metric is nothing but, is finding a way of finding the distance between two pixels. Okay, which has many applications we'll see in future classes. Yes, first let us take 3 pixels P, Q, S. P with the coordinates x, comma, y, and Q with the coordinates u, comma, v, and S with the coordinates w, comma, z. Okay, and always the distance is represented with d, and d of p comma q means distance between p and q is always greater than or equal to 0, never be less than 0. And d of p comma q is equal to 0 when p is equal to q, otherwise it is greater than 0. Okay, then distance between p and q is equal to distance between q and p. Another point, if p, q and s are in a sequence, then the distance between p and s is less than or equal to distance between, means suppose take this p, q, yes, distance between this is less than or equal to the sum of distances between p and q and q and s. That is the third point. Okay. Now, you have 3 types of distance matrix: Euclidean distance, D4 distance or city block distance, and D8 distance. Yes, this is the formula to find Euclidean distance. Root x minus s whole square plus y minus t whole square. The set of pixels having Euclidean distance less than or equal to some value r from the center pixel x comma y forms a disk of radius r centered at x comma y. If you want, you can take one image with different pixels and you can find at least a 5 by 5 pixel, 5 by 5 image, and you just note down, you just mention all the pixels notations and then find the Euclidean distance between the pixels and find the pixels whose the Euclidean distance is less than or equal to some value r. Then, yes, if you indicate all those pixels in the same, on the same 5 by 5 image, all those pixels what seems to be a disk of radius r with the center x comma y. Same. This is the D4 distance or city block distance. The formula is mod x minus s plus mod y minus t. Yes, if you find the Euclidean distance, if you find the pixels, or if you arrange the pixels whose D4 distance is less than or equal to 2, it forms this diamond with the center x comma y. Okay, and why it is called city block distance? If you say this, you can move only front and back or left and right. In the city, you can move only front and back or left and right. You don't have a chance to move or provision to move diagonally. Okay, so that is the reason it is called city block distance. Another distance is d8 distance. This is the formula, max of x minus s comma y minus t. It results the maximum value. In the similar way, if you find the pixels whose d for d8 distance is less than or equal to 2 and arrange those pixels or seems to be like this, forms a chessboard. Okay, so these are all the three distance metrics. So, and overall this is the relationship between, the basic relationship between pixels is we define the neighbors and we define the adjacency, path, connectivity, region, boundary, and then the distance metrics. Okay, so thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.